Coming up on the FRC Open Alliance Show, 2491, NoMythic from Minnesota is back to give us all the awesome updates they've been doing so far. Obviously completed CAD and it looks phenomenal, but we're going to be diving into some of their mechanisms, how that's been working, including they've got their climb working as well, so can't wait to see that, and some crazy cycle times that they're targeting as well too. Going through their prototypes and how they got there is great. I'll be going through other design updates. I'll be talking about some of their programming side of things, how they're looking at doing the odometry, and then utilizing also time of flight sensors as a backup to that as well too. Also be checking out their awesome field that serves as a magnet center for other teams as well too, and talking a little bit more about how they're planning on getting ready for their week 0 and week 1 events. Let's see what their updates are here on the Open Alliance Show. Let's welcome back once again to the FRC Open Alliance Show, 2491. NoMythic coming in from Minnesota, and it's great to have you all back. I know, reading on your build log here, a lot of awesome progress has been happening, so I can't wait to dive into it. If you don't mind, reintroduce yourselves. I know we got somebody else joining us later too, but let's talk more about you all, and then let's hop right into some of your awesome build and design updates.
Yeah, hey there. My name's Liam. I use he, him pronouns. I'm the team captain here on 2491 NoMythic. I've been a student here for about 5 years.
Hi, I'm Aiden. I'm the design captain on NoMythic. I use he, him pronouns, and yeah.
I'm Clover. I use they, them pronouns, and I'm manufacturing, I'm the production captain, and I've been on this team for 5 years.
Yeah. So this year we have a couple of really ambitious goals. One of the first goals that we have is 4 coral by our first competition, which is week 1. We'll see how feasible that really ends up being once we get our hands on an actual robot, but that's what we're shooting for. Additionally, we're looking for about 15 to 20 coral in a match, including auto, which rounds out to be about 6.7 seconds per cycle if we're getting a couple in autonomous as well, and you're assuming we have a climb. And then we're also trying to get to Einstein. Now that might sound really quite crazy, but the goal is that we have something to aspire towards, to look to achieve, and a competitive greatness to shoot for the stars. And we'll see where that ends up getting us. Now, 6.5 second cycles might sound really, really short to you. And so the way that we're going to do that is by doing really good algae pickup, coral placement. We're trying to have a killer drivetrain this year. And we're looking for really quick alignment to the reef with programming. And then a really quick climb at the end, so we have a lot of time to recycle.
So for those 6.5 second cycles on there, are you looking at maybe only scoring on a certain level in order to get that quick, or is that for all levels?
That is hopefully for all levels. Our elevator will move in about half a second.
Yeah.
Up and then half a second down.
Cool. Well, I look forward to talking more about your elevator in a little bit first, but yeah.
Yeah, absolutely. Let's dive into some prototypes.
Do you want me to take it? All right. So here is a little video playing of a few of the prototypes we've been working on. A few of them, I think we probably showed up last time, but the main things we've been prototyping the last few weeks are our end effectors and our climbing. So right now you're seeing a little loop of videos with our funnel mechanism, the then handoff from our funnel to our coral end effector, then our coral end effector actually shooting it. One thing that we definitely really put in the time to work out in prototyping and in geometries was really that handoff. It's not something that we've done in recent years, really have to worry about a handoff between mechanisms. And so prototyping that and making sure that we were confident in that going into the design was a really big thing for us. Moving on, I guess. Here is our algae end effector. Once again, a prototype. This was one of those things as well that we've gone through a lot of different prototyping iterations on. But the main thing that we were using with it, and the main thing we were trying to prototype is the geometries of being able to pick up a coral, place a coral and pick up an algae at the same time. It's something that we've really been striving to do with this robot, and has been a really big determining factor of a lot of our design work. So what you're seeing here is us with a prototyping elevator actually test the geometries that we're hoping to run. And
I love that elevator, by the way. That prototype elevator is so cool. I don't think I've ever seen a team just like manually do something like that. That's really awesome.
Yeah, when the season started, we figured that we needed something to lift our prototypes, but didn't have the time or resources to get a COTS elevator. So this was our solution, and it's been working great for us. So this is those geometries showing us both in the processor, and then eventually we'll show a little picture of it going into the barge. But once again, the big thing with this is we really wanted to try and get that placing coral and removing algae just as quick as possible and at the same time. We noticed it would be a really big advantage in even just those first 6 cycles, just to be able to do both at the same time. But then with those 6 cycles, then scoring into the barge, this was something that I think we talked about last time, that it was more of a, if we can do it, we will do it. But as weeks have been progressing and we're seeing the value of algae in this game, one thing we really wanted to look into is, how easily could we do it? So on the screen, you'll see this blue bar at the bottom next to these 2 pictures of the algae end effector and an algae being shot. This was our way of representing, just quickly, like in reference to the algae end effector, where the barge would be at full extension. And this was our way, as well as in real life shooting it, to determine that yes, our end effector prototype, right, which is severely underpowered compared to the final version, would in fact be able to score in the barge, which is really great for us to see and big confidence booster. So yeah.
Yeah, and then looking at the climb, recently we got the climb to actually kind of function, which is really cool. So in this initial prototype, you're going to notice that the weight is unbalanced. Actually, there will be an image coming up right here. We had to add this little foot. It's kind of blurry, it's kind of hard to see, and I apologize for that. We had to add this little foot to get it to fully pivot and stay in the robot the way we wanted to. But then instead of having a foot, we raised the fulcrum up a little bit, which allowed the cage to come in exactly the way we wanted to. And so in this image, you're going to see it. I'm actually going to skip to this one. This one has 20 pounds on the robot, and you'll see that we're bringing it in. Actually, we're doing this with a worm gear, which means do you want to talk about the worm gear?
Yeah, so last year, this is using a gearbox from last year's climber we had, where we identified that being able to say that our climber can't be back driven was a major advantage, especially when you're only lifting yourself off the ground a few inches. Once again, in a similar game where we're not actually climbing that high, we determined that some method of making sure that once we've climbed a little bit, we're never sinking back down would be really important. So in that prototype, we completely reused that climber, and we're thinking of using a very similar mechanism with a worm gear for this iteration of a climber. And yeah, another thing that I'd like to point out with this prototype is, we made a big note that it had 20 pounds on it. This prototype is made completely of polycarb. And so, as we were climbing, we would notice that the actual hooks started to bend in ways that weren't awesome. And so we're planning on making those pieces out of aluminum to start our next iterations of prototyping. But that's why we weren't able to get a ton of weight on it, because we were worried it would break. This here is a little bit of an extension of our algae end effector prototype. So one thing that we also noticed is that, this algae end effector that we're calling the Big C, it's pretty big. And so in its current position on the robot with the geometries that work, it lays like a foot outside frame perimeter. So this is our mechanism idea to be able to then deploy our coral algae end effector. So this is a really cool mechanism that was put together by a mentor and student. And what this is it is the motor that actuates the pivoting arm down is actually the same motor that actually spins the algae end effector. And so what ends up happening is, because of the friction in the system before it's been deployed, spinning the motor only actually moves down the arm. But once it's fully deployed and hits its hard stop, then it's actually able to rotate the roller. So this was our way of being able to have a quick and very simple and light mechanism to deploy the algae end effector. Yeah.
So here are some things about our drivetrain. So our drivetrain is really low to the ground, about
3/4 of an inch.
3/4 of an inch. So that's the first thing we changed about our drivetrain this year. We also changed our gearing on our swerve. So we changed only one pinion, and it actually is making us a lot faster. And we could have, gotten a bunch of gears and done a lot of different things, but it would have cost us hundreds of more dollars. That really wasn't in the budget. You can also see some wiring diagrams we have. So this is a diagram we use to show what and where our motors and different things on the robot will be placed. And this is helpful for even new students, so everyone can see what they're doing next.
Yeah, and this is done on a program called Fritzing, which we provide resources for on our GitHub. So always feel free to reach out about that on our website. Moving on to Robot CAD.
Yeah. So last time we showed our crayon CAD, and this is what our final crayon CAD really looks like. once again, let that single elevator, 2 end effectors, a funnel, and a climber. And this is what the current robot looks like. So with this, few weeks passing by and all of this work done, one thing that we sadly realized is that our funnel and climber mechanism wouldn't work. We looked at a lot of geometries and really tried, but what ended up happening is that it just wouldn't work with the geometries. So what we ended up doing is then developing a, like you saw earlier, separate climbing mechanism, which seems pretty similar to what a lot of teams are doing. But yeah, one thing that is worth noting about our funnel and climber, though, is that to be able to fit the funnel how we wanted to fit it and everything else, we would actually not have the space to climb, right? The funnel would get in the way of the cage. And so one thing that we're still doing is the funnel still actuates, but this time it moves up and then out of the way of the climber and cage. Oh, a little too much. So that we actually can successfully climb without breaking the rest of our robot.
How is that actually? Is that mechanical or pneumatic?
Yeah, mechanical. So what we're doing is we're using an over-center latch type mechanism on it. And then if you rotate a little bit, you can see we're just putting a Neo 550 on a little spool. So the idea is that we spool in a little bit, pull it over center, and then gravity and some springs will collapse the rest of it. Yeah.
All right. Do you want a quick talk about manufacturing?
Yeah. So when we are manufacturing, we use money.com to keep ourselves organized. This is very helpful when we are divvying up tasks at the beginning of practice, that if someone doesn't know the length, width, height of what they are cutting, all that information is going to be in Monday. Another really big thing we use is Quality Tool, longtime sponsor, and they are producing over 300 parts for us. So this is sheet metal that they would bend and cut. We have 57 unique pieces, so they are doing a lot for us this year.
Yeah, and Quality Tool is also a really helpful sponsor because they're doing the cages for 2 different fields in the Twin Cities this year. And so they're producing the top brackets for those. So we just wanted to give them a huge shout out. And we're going to move on to programming.
Hi, my name is Rowan. I use he, him pronouns. I'm the programming captain on team 2491 NoMythic. I'm going to talk a bit about what the programming team's been doing. So, while the build has been developing prototypes and manufacturing, while build has been developing prototypes and manufacturing, programming has been creating outlines of code for every subsystem in preparation for receiving the robot. Additionally, we've been developing code to automatically line up our robot with the individual reef poles on the field. We plan to use Pathplanner with our Odometry to pathfind to the individual reef poles on the field. But what you'll also see here is that we've developed a backup method in case our Odometry encounters hiccups during competition to line up with the reef poles using time of flight sensors. So our robot can approach the reef using time of flight sensors and also line up side to side. Last week, programming received from Build our finished practice spot drivetrain. So we took it to the HCPA practice field to test it.
Yeah. So the HCPA field is a field that is a local resource to all Twin Cities teams. It's something that we set up. Mark and Toby are 2 of our mentors who take this on every year. This is also done in association with the Minneapolis Urban Robotics Association, or MURA for short. And the Hmong College Prep Academy gives the space for that. And that's a huge resource for us. We don't get to use that every day. We have to use that about once a week. And because of the split in resources with April tags, it's been really, really important to us. So yeah, that's what we have for you today.
So I want to ask about this field real quick. You say you only can use it like once a week. Is that because it's split amongst other teams, or like how does that work in terms of separating with all the other teams that are using this?
Absolutely. So we can only use it once a week because it's split with other teams. Even though we provide a lot of the resources, the building's just not open that often because of the way the school works.
Okay. And something I want to ask you in particular is like from creating that, I think one of the great things we're seeing all around, the world, honestly, are these kind of magnet centers, right? For especially these large metros to bring in teams for that as well. For other teams that might be looking at getting something like that started, any advice that you have for like teams or programs or like want to create something like that?
So the hardest part is getting the physical building space for that. The actual field and the field setup can be done really cheaply with plywood and volunteers and all of that. But getting a physical permanent space is the hardest part. So looking for schools, looking for sponsors, getting hub groups together. We have a bunch of teams working on this together, all pooling money to get this resource for the community. It's really important to have a full field now more than ever, or really a half field that's permanent, because of April tags and what that does for programming and what that does for drivers.
You have a week 0 event coming up, the Blue Twilight week 0, very shortly, and then you're playing week 1 as well too up in Duluth, right? So like, what is your next steps really look like to get ready for that week 0 event? And then between week 0 and week 1, what are kind of your key things that you want to get done?
We want to get done a robot,
Sure.
which is a lot of work. So we're hoping to get our practice bot done first, which can go to those week 0 events, and to have that at the events, and then having our CompBot robot here that programmers can use and drivers can use to then get ready for Duluth. So we are as good as we possibly can be.
I really hope, by the way, that we get to see some of the cool purple aesthetic in the actually completed robot. It looked really cool in CAD, so we're looking forward to that. And speaking of aesthetics as well, too, who's the mascot you got in front of you?
This is Frank. He has been on our team for about 3 years, and he is our emotional support unicorn.
Awesome. Well, Frank and all of NoMythic, thank you so much for coming on to share your progress. I can't wait to see how you do in week 0 and week 1 as well. Your team has been really just kind of growing so much, both from a robot side of things and just the community building side. So best of luck to you, and make sure you're following their build log out on Chief Delphi to get all their great updates. Thanks a lot.
Thank you. Bye.
Thank you.